All right, Kate, let's go over these last problems. So here you have to find all of the zeros. List your P's and Q's first. So I have plus or minus 1, 2, 3, and 6. So 8 possible answers all over 1, so that doesn't really change much. And then I'm going to start using synthetic division. So let's just start with 1. So I have 1, and now I'm going to list all of my terms up there. Make sure if something's missing, you put a 0. So x to the 5th is 1, coefficient of 1. X to the 4th is negative 2. X to the 3rd, I don't have 1, so I have to put a placeholder of 0. X to the 2nd is 8. X to the 1st is negative 13, and then positive 6. So now I'm going to go through the process. 1, multiply, get positive 1, add it, negative 1, add it, negative 1, add it, 7, add it, I get negative 6, and now I get 0. It works. So x equals 1 is part of my solution. Now I need to find 4 more, because this tells me how many solutions I'm going to have. So let's try this second one. So now my highest degree is a 4. So this is 1x to the 4th minus 1x to the 3rd minus 1x to the 2nd plus 7x minus 6. And my paper real quick so we are not here all day. Let's see if I already have all my worked out solutions here. So let's use 1 again. Because remember, with every new synthetic division we do, we can repeat our numbers. So let's give it a shot. We get 1, bring it up, add a 0, times 1 is 0, add negative 1. So it works. All right, keep going. So this is my new equation. My highest exponent is now a 3. So I have 1x to the 3rd, 0x squared, negative 1x, positive 6. And I'm going to try negative 2 just because I did it ahead. And I tried 1 and negative 1 already. 1 times negative 2. I add is negative 2. I multiply, I get positive 4. I add, I get 3. I multiply, and it works. So we have 1, negative 2, 1 so far as our answers. Now, since this highest degree is technically an x squared now, I'm going to use the quadratic formula because it will make time go by a lot quicker instead of doing synthetic for everything else. Label my ABC and plug it to the formula. B squared. Oh my gosh. Opposite of B, plus or minus B squared minus 4 times A over C times 2 over 2 times A. Start filling in. Opposite of B is positive 2, plus or minus negative 2 squared minus 4 times A times C. All over 2 times A. Simplify. I get 2 plus or minus 4 minus 12 all over 2. Keep simplifying. 2 plus or minus negative 8 all over 2. Don't cross this out yet. Don't cross out the 2 2's. Simplify the radical. I get 2 plus or minus I radical 8 over 2. Now we want to simplify the radical 8. Radical 8 we can break down. Remember, always think about factors that are perfect squares. Well, 4 is a perfect square, and it simplifies to 2. So radical 8 actually simplifies to 2 radical 2. We're just going to tack an I in between plus or minus. So this radical 8 we simplified to be 2i radical 2. Now you can split it up because technically you have two parts, right? 2 plus 2i radical 2 over 2, lots of 2's, and 2 minus 2i radical 2 over 2. Now we can start canceling out. These cancel out and those cancel out. So you're really just left with 1 plus I radical 2 and 1 minus I radical 2. Your final two zeros out of all 5. We can add them up here to our answers. And 1 minus I radical 2. Lots of work for one problem. Okay, now we're going to jump down for when I give you zeros and you have to find the polynomial expression. So we have to set them up as if they were in polynomials. So given the zeros 5, 5, 4 plus I, with the leading coefficient being 1. So 5 actually translates to x minus 5, because if we equal it to 0, you add the 5 over, the 5's positive. I'm seeing that twice. And now this 4 plus I, you really have x minus, right, because the 4 is positive, 4 plus I, and again, x minus 4 minus I. You really have those two answers there. So now we have to start the foiling process. So I'm going to FOIL this first part. I get x squared minus 10x plus 25. This one, I'm going to regroup my x and my 4 together. I'm going to use a big bracket this time because I hate double parentheses. And I have x minus 4, and then I and negative I. Regroup in what we're multiplying together. So we can FOIL this guy to be x squared minus 8x plus 16. And I times negative I is negative I squared, which translates to 1. Bring my outside trinomial down. And now I can combine these two terms because they are both constants, so they are alike. And in the center now I have x squared minus 8x. 16 plus 1 is 17. And on the outside I have x squared minus 10x plus 25. Now you can multiply, one at a time in. My favorite method to use when multiplying a trinomial times a trinomial, and it might look a little grade schoolish, but it's fun to be a kid. Oh my gosh, everything's erasing. There we go. So in the top, I'm going to put my first equation, x squared minus 10x plus 25. And on the side, I'm going to put my second equation, x squared minus 8x plus 17. And you're going to multiply column times row. So x squared and x squared gets you x to the 4th. Negative 8x times x squared is, I'm sorry, negative 10x times x squared is negative 10x cubed. 25 times x squared is 25x squared. Now I'm going to do the second column and row. X squared to negative 8x is negative 8x cubed. Negative 10 times negative 8 is positive 80x squared. 25 times negative 8 is negative 200x. And last column and row, I have 17x squared, negative 170x, and then I have this constant here, which is 425. Now to combine my like terms, we add the diagonals. So everything diagonal will have like terms. What makes it very easy to add them together. These two do not have like terms, so they are in my final answer. X to the fourth. My yellows, I get negative 18x cubed. My blues, if I add them all up, I get 122x squared. My pinks, I get negative 370x. My last, 425. So here's my polynomial function. It has an exponent of 4, and they gave me 4 zeros to work with. This one is just supposed to be plus minus. So it works. All right, now you have this extra practice problem, find all the zeros of the polynomial. I don't even think I did. Oh, I did do some of this one. So I'm going to start solving it with you. List the P's and Q's. 1, 2, 3, 4, 6. So there's a good handful of them. My highest exponent is 4. So I'm going to work it down and use synthetic division until I get exponent of 2. I'm going to start with negative 1. It's all over 1, but that doesn't change anything. All right, let's try negative 1. List all my numbers up here. Make sure you put a placeholder if you're skipping an exponent. So we have 1, 4, 7, 16, and 12. No skipping here. We get negative 1, add 3, negative 3, add 4, negative 4, add 12, negative 12, add 0. So now my highest degree is an x cubed. Almost there. So let's rewrite it. 1, a different color so it doesn't all blend in. 1, 3, 4, 12. I could use my 1s again, but I already went ahead and did, and it didn't work. I used my 2s, didn't work, so let's try negative 3. I get negative 3, add 0, add, and it works. So now at this point, my highest degree would be an x squared. So now I can use the quadratic formula. I'm going to put it over here. X squared, there's no middle term, it's just plus 4. I can't use the difference of perfect squares because this is an addition sign in the middle, so I have to use quadratic formula. A, my B equals 0, C is 4. So opposite of B, 0, plus or minus the square root, 0 squared minus 4 times A times C, all over 2 times A. Simplify, 0 plus or minus negative 16 over 2. Simplify, 0 plus or minus I, 16 over 2. Let's show my side work. Oh, well, 16 actually is a perfect square. So it's 4. That one was easy. So now I have 0 plus 4i and minus over 2. 4i over 2 and negative 4i over 2. They simplify to be 2i and negative 2i. That one wasn't so bad. I should have 4 possible zeros. I do. Negative 1, negative 3, 2i, and negative 2i. And if I wanted to check, I could take any of those zeros, plug them into the original equation, and I should get 0. That would be the way we check.